let's go one more thing here. Okay. This will be the ticket. Okay. So all agents right now travel at the same default velocity. I'd like you to modify the model so that when the agents get infected, their velocity changes to a certain fraction of its original value. Its original value is 10, and I'd like it, when they're infected, to be alpha times 10. Alpha will be a parameter specified to the whole model. It'll be something we can vary for different experiments. And then when they recover, it goes back to 10. Ladies and gentlemen, guide me as to what I should do.
Infection state chart.
Okay.
If it's in infectious state.
Okay. Infection state chart for a person. If they're in an infectious state, yeah.
The velocity will change to
Good.
alpha times.
Good. And will we need to recover it at some point? When they recover, so where could we put that?
That actually doesn't make any difference to our model because recovered people don't exact things.
Correct. That's correct. So it doesn't matter if they switch back to that velocity, except in as much as they may take some of the arrows that otherwise would have been shot at the susceptible. So if they're the closest one, they may get infected rather than a susceptible is also close, right? So they may take some of the slings and arrows of the infectives.
We should keep moving fast to protect the
Okay. So, ladies and gentlemen, what else do we need? We need an alpha. Where are we going to put an alpha? Sorry? Yeah, it's a parameter. Okay, parameter to what? Okay, yeah, it'll be a global parameter. So, ladies and gentlemen, let's go to main, and let's go add a parameter. Okay, so we're going to go to main, and we're going to add a parameter. Okay, and this parameter is going to be alpha. I'll call it, but I'll call it, alpha. Speed coefficient, so we remember what it is in the fullness of time. Okay, so alpha speed coefficient. Ladies and gentlemen, if I want this to be a value between 0, some non-negative value, what would this be? What's their data type? Is it a string? Is it a Boolean? How about someone not from computer science? Okay, good. Excellent. It's a double precision value. Good. And that's great. So now how are we going to reflect that in the state chart? Well, when they get infected, okay, we could put it here, or we could put it in the entry action. I tend to have a slight preference for putting it in the infection transition, with the proviso that if we had multiple of them, if like we had one that was one type of infection via needle, another type of infection via sexual contact, you'd put them in the entry action. But okay, so in the action, what are we going to do? How are we going to change them so they change their speed, their velocity? Good. What are you doing to their velocity? You are, what is it? You're setting their velocity. So this dot set velocity. There you go. Okay. And we want to set it to whatever their current velocity is times alpha. Yeah. Okay. So this dot get velocity, right, times, And I like Farhad prefer the alpha times it. How are we going to get alpha though? Can we just write alpha? Alpha speed coefficient? We have to, where does alpha speed coefficient lives? It lives in main. So we need this dot get underbar main to ask main, hey, you know, main, could you tell me your alpha? Right? And we can ask for its speed coefficient. Does that make sense to people? Okay, so here we set the velocity there, and then how are we gonna restore that velocity back?
When change from
Recovery, yeah. We can multiply times 1 over alpha as long as alpha is not 0. And maybe we want to allow for alpha equals 0. So what would we do? Suppose we were in that situation. How would we remember what alpha was? What was my original speed? How could we do that? How could we remember? Kurt?
Put parameters at speed.
Sorry?
I just had parameters and then LP speed and effective speed.
Yep, that's one way to do it. Another way, if we wanted to, is we could remember it. We could insert a variable that was like, you know, original speed, right? And when they come in, their original speed, we remember their original speed. So we set their original speed to be equal to their current velocity, right? And so, in other words, we could remember away their original speed, remember it here, and then, you know, set them to be the speed times alpha coefficient. And then when they recover, we could do what? Set their velocity to the original speed. I agree with Kurt that it may be worth just having two parameters, one and one the other. After all, you don't have to do that computation once. But Kurt, this current design allows for heterogeneity in speed. So you could have some agents that are speed demons and some that are really slow. And you could capture that a little bit more flexibly. So there's some trade-offs here. Okay, who needs professor help?
what if the initial value of alpha is 0?
Well, we're going to have an alpha initially of 1 just to test that things look the same as they did before. And then we'll have a value of 0 that we'll say. Original velocity. So you're going to need a variable called original velocity. Yeah. And that's a double. Original velocity. Good. Good. And yep, and then go back to that place up there. Yeah. And then you're gonna scroll down here, and then you're gonna do original velocity equals this dot get velocity. It's their current velocity. Okay? So up here their original speed we remember their original speed and we use their original speed, but later we use the original speed times something, but later we restore their original speed coming in here. Does that make sense? When they come into recovered? Okay, who needs professor help? Yeah. Sir? Yeah. Okay, sure. The infection transition has two broad sets of things in it. Thing one that it has in it is it has a thing to accumulate the infection count. That was from before. But secondly, it has something which sets the original speed, this variable called original speed, which I dragged from over here. And then secondly, it sets their velocity to this alpha times main, which is from main, times their original speed. Okay. Who else needs professor help? Okay, I would suggest, ladies and gentlemen, as a general principle, when testing this, test it first for an alpha of 1, because that should give results that are familiar, right? That's what we've been doing. It should give the same basic results as before. And then test it with an alpha that's different than 1. How about an alpha of 0? How would that be different? What's that?
They just stop and
They just stop.
Depends on the way.
What's that?
If we use another variable to
Yeah.
have another parameters to remember the previous velocity.
If we had another variable?
What if we don't use original state variable and just divide it by alpha
Right.
after recovery?
Then exactly, that's why we didn't do that. That's what I would say, but if it's 0, that doesn't work. Okay, so ladies and gentlemen, we do have to, where does that alpha get specified, ladies and gentlemen? In simulation, in the experiments, in other words. It's an assumption we make about the entire character of sort of the model, the assumption we make about the model as a whole, I should say. And so we can go to parameters on the experiment, and there's an alpha speed coefficient. Let's test it with 1 first, just to make sure the dynamics are basically as observed. Okay, watch this. And we should see those dynamics. I did switch it back to a rate transition. So here we have this turnaround. It's not going up quite as far as before. And here we have this rate-driven transition here. Okay. Okay. By the way, ladies and gentlemen, why is it going so slow? Why does this go? Why is it working? Why is it going slower now than before? Well, it turns out that it's doing a lot of work. It's processing a lot of events as part of this process. And you'll notice it's a lot of the events it's doing, for example, are infection events, recovery events, etc. Just there? Yeah, I set it back to a rate transition. Yeah, it was a rate transition. Okay, so ladies and gentlemen, how if I do it with a small alpha? Well, we could do this with large population, but ladies and gentlemen, I'm going to copy this. I'd like you to pay attention to this, okay? So, so let me just